These are systems that play for you music that you might like based on some kind of long-term preferences of you as a user. And what's common for most of these systems is that they are functioning based on this long-term profile, and they don't assume anything about the actual situation when the user is listening to the music. However, as we know, with all the technologies that we have, people consume music in very different situations. And we believe that this environment of the user when listening to music, we can call it context, it has an impact on the user's music needs, so music preferences at that point. So context matters, and it can be also seen from the growing number of research articles that are addressing this issue. So recommending music in context, and there are different types of context information that can be used to somehow tune music recommendations. And our focus is on location of the user. Particularly, we want to find music which fits a place of interest. So let's say some tourist attraction that the user is visiting when receiving music recommendation service. And the possible applications for such a service could be a mobile tourist guide. So for instance, a mobile application that recommends an itinerary to a tourist and then plays the soundtrack which matches the visited places. And it would enhance in a way the sightseeing experience, and also potentially would allow you to discover interesting music that you didn't know. We can also imagine a car music player which would adapt music as the car is passing different places. Of course, this would have to be done on a different scale because you're moving faster, but the idea would be to adapt to some kind of landscape or scenery. And there can also be another application for that type of service where we could find music which fits certain attractions because of some semantic relations. And in this work we are focusing on this type of music adaptation. So we want to find music which is somehow relevant to a place because of some semantic meaning that it has. Okay, so after this briefing address, we want to automatically identify music or musicians, as I will explain it shortly, that are highly related to a particular place of interest, and in such a way that we get this data from existing repositories. And I will show later that we are using living data repositories for that. And we want to do it in a way that the users would recognize this recommendation and will appreciate the match that we produce. So it has some kind of classification for all the resources that are there. So at the bottom of the Wikipedia page, we have these categories, which are kind of classes to which this information units are assigned to. And on top of Wikipedia, researchers have built this ontology, which is DBpedia, which is the linked data repository containing all the information that we have in Wikipedia. And in our work, we are using DBpedia as the source of knowledge that would allow us to find this link between the different domains, music and places. So in DBpedia, we have classes, let's say like opera houses, and we have instances like Vienna State Opera, for example. And then as a second step, once we know which types of relations to search for in Wikipedia, we can instantiate this class network for a particular place that the user is visiting, for instance, Vienna State Opera. And then once we are able to identify all the possible musicians related to that place, we have to somehow compute the relatedness score between the place and the musicians. And for that, we have adapted a weight spreading algorithm. So the class network is this subgraph of Wikipedia that we identified as useful for finding music which is related to a place. The weights between different nodes can be set manually by, let's say, a domain expert, or this can be an option to use a personalization for the user. For instance, we can boost the link between opera houses and opera if we know that the user prefers opera genre. Or we can boost the importance for a historical era if we know that the user is more interested in that place. Then we compute the related score for all the musicians that are in this network. We can random the musicians according to the score and recommend top N to the user. Since the users cannot evaluate a large number of these recommendations in a survey, we limited the data set of places of interest to 25 well-known places. And this includes historical monuments, castles, churches, and so on in major European cities. And then, in addition to the weight spreading algorithm which I introduced, we also used 3 baseline algorithms, 2 famous graph-based algorithms, HITS and PageRank, which explore the global structure of the graph to compute a score for any node, and 1 random, which was basically selecting a random musician from all the musicians available in the instance network of a place. The goal of it was to see whether the users will agree with these semantic relations that we find between the place and the musician. And so we developed a kind of complex interface which requires considerable effort from the user, but this allowed us to really evaluate whether these semantic paths that we are finding make sense to the users. Then we also compared which types of the semantic paths the users found useful in the recommendation. So we had those musicians that were marked as related by the users and those that were marked as non-related. Then we could check how our algorithm perceives these relations and how the users actually agree or disagree with that. And here also weight spreading was most consistent with the user judgment because for those musicians that the users found not related, the algorithm also retrieved less semantic links. Additionally, we also checked the influence of users' genre preferences just to see whether this has to be taken into account. And it turned out that yes, when evaluating this precision of our approach for different genres, for certain genres, there is a high probability that the users will like this approach. So to conclude, we can automatically identify musicians that are semantically related to the given place of interest, and the users agree with the musicians that we retrieve. Also, the music composed or performed by these musicians is found as relevant for the places, and we confirm that genre preferences have to be taken into account in the future work.